Hello viewers and welcome to the lesson. In this lesson, we shall go through grade 10 core mathematics as we continue to prepare for the Kenya Certificate of Basic Education, that is in the year 2028. This paper has two sections. We have section A, 20 marks, multiple choice questions where you're supposed to indicate only the correct answer, that is A, B, C or D. Then section B has 80 marks, that is the structured questions. Now I've listed all the testing areas in the paper. They are there. And please don't forget to go to the description of the video. I've left the link to get this question paper. You can get the question paper, download it, and then you print. And before we go through the paper, you can try to attempt it, work it on your own, and then later on you can view the progress on how you're supposed to do the workings. Now we shall start with section A, the multiple choice questions. So let us go to section A. So section A is here. Question 1, you have the working space there. Which list contains only composite numbers? Only composite numbers. So for this question, you need to understand what is a composite number. Before you answer it, you need to understand. So a composite number is any number that has at least one factor rather than 1 and itself. You know that a number that is only divisible by 1 and itself is called a prime number. So we're not looking for that. A composite number is that number that, apart from having 1 and itself as a factor, it has at least another one factor. It can be 1 or more. Now look at the solutions that are here. When you look at solution A, 21 is a composite number because apart from having two factors, that is 1 and itself, it has 3 as a factor, it has 7 as a factor. That means those numbers can divide 21 completely, evenly, without leaving any remainder. We have 27, the same, 35, the same, and 49. And for that particular solution, I already find that to be the solution. Let us go to B and see what is making B not the solution. The first one is 19. 19 is a prime number. So 19 has only two factors, that is 19 and 1. That is 1 and itself. That is a prime number. So we are not looking for a prime number, we are looking for a composite number. So B makes the whole thing incorrect. Then go to C. See, when you look at 29, 29 is also a prime number. So we are looking for a number that has more, at least one factor. Rather than 1 in itself, it should have another factor. 29 is a prime number. So anywhere you find a prime number, you cancel that because a prime number is not a composite number. Then for D, we also have 37. 37 is making everything again to be wrong. So the solution therefore is A. A is the correct one. 21, 27, 35 and 49, all those have other factors rather than 1 and itself. We go to question 2. Which of the following numbers is irrational? Which of the following number is irrational? So again, for you to solve this question, you need to understand what is an irrational number and also what is a rational number. So let me start with rational. So what is a rational number? A rational number is that number that can be expressed in the form A over B, where A and B are integers and B should not be equal to 0. So it is possible to express when you look at A. You know, you're looking for an irrational. An irrational number is that number that you cannot express in this form. A number that cannot be expressed in the form A over B, where B is equivalent to 0. So when you look at 49, 49, the square root of 49 is 7. Square root of 49 is 7. And 7 can be written as 7 divided by 1. So you can see you are able to express that in the form A over B, and therefore that is a rational number. Let's go to B. B is 0.272727. So that is a number that is recurring. 27 is recurring. So is that a rational number or is it an irrational number? Now, 0.272727 can be expressed in the form A over B. You've learned how to express recurring decimals to fractions. So when you convert 0.27 recurring, 27 is recurring, that one, it will be possible to write it as a fraction. So in that case, B is a rational number. B is also a rational number. And I would like you to check that. Try to express 0.2727 as a fraction. You'll notice that it is possible to express it in this form, A over B. Then 3 over 8, of course, that is so direct. That number has already been expressed in the form A over B, where A is 3 and B, so that one is a rational. So this is a rational number, A. Then B is also a rational number. And then C is also a rational number. And then definitely D should be the solution. Look at root of 20. Root of 20, we can't get an exact root of 20. And actually, if you actually use your calculator, so if you try to get the root of 20, you'll notice that this is non-recurring, and you get 4.472. It is non-recurring and it is non-terminating. So again, it is worth noting that when we talk of rational numbers also includes the terminating decimals and recurring decimals. All those are referred to as rational numbers. Then for irrational numbers, the numbers that do not terminate and the ones that do not recur, those are what we refer to as irrational numbers. So that information is very important. So for this part of the question, D is the right solution. So that is root of 20, and that is the one that is irrational. Let's go to question 3. For question 3, you're supposed to find the reciprocal of 4 and 1 over 4. 4 and 1 over 4. This one is a mixed number. So the first thing we need to do is convert that mixed number into an improper fraction. And this becomes 4 multiplied by 4 plus 1. That will be 17 divided by 4. Then get the reciprocal of these. The reciprocal of these will be 4 divided by 17. That was so straightforward. So the first step, convert 4 and 1 over 4 as an improper fraction, which is 17 divided by 4. Then get the reciprocal or the inverse of 17 over 4, which is 4 divided by 17. So that is solution B. We go to question 4. Question 4, a tap fills 2/3 of a tank in 24 minutes. How long will it take to fill the whole tank at the same rate? Again, these are question testing on reciprocal, this application. So a tap fills 2/3 of the tank in 24 minutes. So how long will it take to fill the whole tank? So that means when the tank is full, therefore it will be 3 divided by 3. 3 divided by 3, or simply 1. So if 2/3 of the tank is filled using 24 minutes, so what about when the tank is full, which is a whole fraction, that is 3 over 3 or 1? So you just need to cross multiply. So 3 over 3, which is 1, then multiply by 24, and then you multiply. This is why we have now the application of reciprocal. Multiply by the reciprocal of 2 over 3, it will be 3 divided by 2. And this gives, by 2 and by 2, this will give 12. So 12 times 3, this gives 36. So that was just a matter of cross multiplication. Again, you can say 1 multiplied by 24 divided by 2/3, which is still the same thing here. So that is 36 minutes. Then question 5. Question 5 is on indices. Simplify. Here you are going to apply the law of multiplication, and I'll remind you the law. Given a raised to power m multiplied by a raised to power n, this is n. When you have these values and you're multiplying them and the bases are the same, the condition is that the bases are the same, so you are going to add the powers m plus n. So in this case you have 2 power 3 and then 2 power negative 1. So applying this law, we have 3 plus negative 1, and this gives 2. 3 plus negative 1, that would be 3 minus 1, which is 2, and 2 squared is 4. So the solution there is B. Question 6. Express 125 as a power of 5 as a power of 5. So this is how we go about it. So 125. So we divide this one by 5 because we want to give this in form of index form with the base of 5. So divide 125 by 5, you get 25. Divide 25 by 5 again, you get 5. Then divide 5 by 5 and you get 1. And this gives 5 multiplied by 5 multiplied by 5, and this gives 5 cubed. Question 7. Evaluate 27 raised to power 2/3. 27 raised to power 2/3. So you can start by expressing 27 in index form with the base of 3. So 27 can be written as 3 cubed. 27 is 3 cubed, and then you raise these to power 2/3. So this gives 3, and you have 3. Opening this bracket, you just get the product of the powers, 3 multiplied by 2/3, and this gives by 3 1 by 3 1. This gives 3 squared, and 3 squared is 9. So the solution there is C. We go to the next question. The next question here is question 8. Question 8 is on indices. Question on indices. 3 power x plus 1 is equals to 81. So the first thing you'll do, you look at the right hand side. Is it possible to express 81 in power form to the base of 3? Yes. 81 is the same as 3 to power 4. 3 power 4. So you express that with the base of 3 in power form. And then since in the left hand side we have the base of 3 and also the right hand side, so you simply pick the powers. So you have x plus 1 is equivalent to 4, and x will be given by 3. So that is question 8. Question 9. Which logarithmic statement is equivalent to 10 cubed is equals to 1000? So in simple terms, in that question you're required to express these. Already it is written in index form, so your work is to write it in logarithmic form. So note that if you have a raised to power m is equals to n, that is written in index form, and you want to write this in logarithmic form, it will be logarithm of n to the base of a is equals to m. Now use that to work out this. So 10 cubed is equals to 1000, so this will be logarithm of 1000 to the base of 10 is equals to 3. So that this is the index form, and then this is the logarithmic form. So which solution is that? That is solution C. Question 10 again, this is the same, another question still on the logs. So you given log of 2, base of 10 is equals to 0.3010. Find the log of 80. So logarithm of 80 to the base of 10 can be written as logarithm of 8. You can split these 80 to be written in terms of 8 multiplied by 10. 8 multiplied by 10 is still the same. We've just splitted 80 so that we can make it easier for us to utilize log 2. So where exactly are we going to utilize log 2? When we split it like this, remember the laws of logarithm. Logarithm of 8 multiplied by 10 is the same as logarithm of 8 plus the logarithm of 10. And don't forget that all these are to the base of 10. Then logarithm of 8, you can write it as logarithm of 2 cubed. 8 can be written as 2 cubed in power form to the base of 3, to the base of 2, I mean. Then logarithm of 10 to the base of 10 is 1. Note that logarithm of a to the base of a is 1. This is a very important concept as far as the logs are concerned. So with that, we can proceed and have this again, logarithm of 2 cubed. This can also be written as 3 logarithm of 2 to the base of 10. That is also another important concept that you need to understand about logarithm, that logarithm of 2 cubed can also be written as 3 logarithm of 2 to the base of 10 and then plus 1. Now this is the point where now we utilize this. You're given logarithm of 2, so you'll have 3, and then logarithm of 2 to the base of 10 is 0.3010 and then plus 1. And when you work out these, you're supposed to get so 3 multiplied by 0.3010, then you add 1. This one should give you 1.9030, and that solution can say it is C. Question 11, you're supposed to expand. You're supposed to expand these. How do you expand these? You take x and then multiply by the second bracket, which is x plus 2. Then you take -5, the second term there, -5, multiply by the second bracket again, which is x plus 2. Once you do that, x multiplied by x is x squared. Then x multiplied by 2, that is 2x. Then -5 times x, that is -5x. And then -5 times +2, that will be -10. We proceed. These will be like terms together. X squared, 2x subtract 2x subtract 5x, that will give -3x. You need to be very careful there. That is the work of integers. And when you look at whatever we have there, the solution will be A. You can see the solution is A. Just confirming that is the right. So question number 11. The solution is correct. That is A. We go to question 12. Question 12 is a question on factorization. When you are doing factorization, you need to get two numbers whose product is the coefficient of x squared is 1 and the constant term is 10. So product, you get 10, and then the sum, that is when add the two numbers, you get 7. So you're looking for two numbers. When you add them, you get 7. When you multiply them, you get 10. Where did I get 7 and 10? 7 is the coefficient of x, and then 10 product is the product of the coefficient of x squared, which is 1, times the constant, which is 10. So which are these numbers? The numbers are very easy. 5 and 2. 5 and 2, you add them, you get 7. Multiply them, you get 10. Now, this gives x squared. Now 7x, we're going to write it using 5 and 2. That will be plus 2x plus 5x. That is 7x plus 10. Then you factor out, so x is common, so you have x plus 2 and then plus 5x plus 2, like that when you factor out. And then now from here you have x plus 5, then multiply by x plus 2. So that is the solution, x plus 5, x plus 2. This one is the correct answer. So doesn't matter which one comes first. You can begin with x plus 5, then multiply by x plus 2, or you can begin with x plus 2, multiply by x plus 5. So the order does not matter. So we go to question 13. For question 13, you're supposed to solve this. So for us to solve this, again, we need to first factorize. And we factorize by getting two numbers whose product is 14 and sum is -9. So which are these two numbers? These numbers are -2 and -7. When you multiply them, you get 14. When you add them, you get -9. So now we have x squared, -9x. I'll write it in terms of -2 and -7. So -2x, -7x. So -2x subtract 7x, that will give -9x, plus 14 is equals to 0. So factor out x minus 2 minus 7, and then x minus 2, x minus 2 is equals to 0. Then from here we have x subtract 7, x minus 2 is equals to 0. Then from here you have x minus 7 is equals to 0. If you solve these, you'll get x is equals to 7, and x subtract 2 is equals to 0. If you solve these, you get x is equals to 2. So you have two solutions, x is equals to 7 and x is equals to 2. So that is the solution A. Question 14. Find k if x squared plus 12x plus k is a perfect square. So if this is a perfect square, then for us to get the constant term, there is a formula that we use. I'm going to show you. So if you have a standard quadratic expression in form of ax squared plus bx plus c. So if you want to get c, that is the constant term, you simply take half the coefficient of x. The coefficient of x is b. Get half of that and then you square. That will give you c. So in this case, what is the coefficient of x? The coefficient of x is 12. So get half of it. So now to get k, you'll get the coefficient of x, which is 12. Get half of that and then you square. And this gives 6 squared, and 6 squared is 36. So 36 is the solution. We go to the next question. And the next question is question 15. Question 15 is the next. So question 15. In two similar triangles, a side of 6 centimeters corresponds to 9 centimeters. Find the scale factor from the smaller triangle to the larger triangle. So the key word here that you're supposed to understand is the scale factor from the smaller triangle to the larger triangle. So how are you supposed to give that ratio? This is the most important part. Most of the learners would make a mistake by getting that ratio by making the smaller to be at the top, the smaller length to be at the top, and then the larger to be at the bottom. That would be wrong in this case. But if the question had asked, find the scale factor from the larger to the smaller, we would have used these. But now for this one, we're going to use this ratio. So you're going to get the corresponding length of the larger to the smaller, So the length of the larger is 9 and then the smaller is 6. So when you simplify these by dividing, you divide the numerator and the denominator by 3, you'll get 3 divided by 2. And since we don't have that solution, we will definitely make sure we divide these and get 1.5. We get 1.5. 1.5. And that is the case what you're supposed to do. So that is how you're supposed to solve that. So most of the learners would give a solution A, of which I've explained why that will not be the case. So you're going to use that. Question 16. If a figure is enlarged by scale factor 3, find the ratio of the area of the image to the area of the object. The area of the image to the area of the object. So for this question, you need to know the relationship between linear scale factor and area scale factor. Now, area scale factor is obtained by getting the linear scale factor and you square that. So in this case, we have the linear scale factor. And remember, this is very important. It is the image to the object. The image to the object. So the figure is enlarged by scale factor of 3. Scale factor of 3. So we need to be very keen when it comes to that. So when you're giving the ratio, we need to understand the image to the object. So the image should be at the top and then the object should be at the bottom. That is the denominator. So since the object, we assume that the original object was 1. And when it was enlarged by 3, you just multiply that by 3, you get 3. So this gives us the linear scale factor. So linear scale factor is 3:1. 3:1. So you can write this in ratio form, it will be 3:1. So that is the linear scale factor. The image, of course, will be bigger, it will be 3, the object will be 1. Then you need to square these. So when you square these, you'll get 9/1. And this one, when you write it in ratio form, you'll get 9:1. And that is solution C. Now after that, we go to question 17. Find the image of -4.7 after reflection in the x-axis. So for that one, you don't need to draw. You just need to know when the x-axis acts as the mirror line, how is the object, or how is that kind of a reflection? And in general, if you have a point A, B, and it is reflected along the x-axis, this time the x-axis acts as the mirror line, then the image becomes, so what changes in the x-axis and what remains the same? What changes and what remains the same? If you draw the Cartesian plane, this is the x-axis, that is the x-axis, this is the y-axis. So you have a point here, that is, let's say A. Of course, the image will be there because the mirror line should be between the object and the image. So when you look at this, the x coordinate remains the same. It remains the same. Whereas the y coordinate changes the sign. If it was positive, it becomes negative. If it was negative, it becomes positive. So in this case, we have -4.7. We have -4.7. So we've noted that what remains the same? The x coordinate remains the same. The x coordinate remains to be -4, but the y coordinate changes the sign, so it is 7. That becomes -7. So the solution there is B. So the solution there is B for question 17. We go to question 18. two right angled triangles have equal hypotenuses and one corresponding shorter side equal. Which congruence condition applies? So in this type of congruence, it is the one that involves the right angled triangle, where we have the right angle is there, and that is what you're going to check in the solution. And then there is the hypotenuse, and then there is one side. So when you look at solution A, those are the three sides, so we don't have any right angle here. And then for B, again, we have the two sides given and included angle. But for C, that becomes a solution, since that is where we have the right angle, RHS, R for right angle, H for the hypotenuse, and then S for the side. The other one, again, we don't have the right angle. So that question was very straightforward and easy. Question 19. How many of the points A, B, and C there and D remain fixed under reflection in the y-axis? Remain fixed means what? That those points do not change when they are reflected along the y-axis. So what is going to guide us is any point that is going to lie, because y-axis is acting as the mirror line. If you're reflecting something along the y-axis and the y-axis is the mirror line, so it means all the points that lie along that mirror line remain fixed and they remain unchanged. So in this case, any point that lie along the y-axis will not change. And which are these points? 0, 3. 0, 3, probably it will be there. That one is 1. -2, 4. -2, 4 does not lie. This one does not lie along the y-axis. Then 0, -5. 0, -5, probably it will be there. So A is there. Then C will be somewhere there. And then we have 6, 0. 6, 0 will be somewhere here. So it will not. The only points that will lie along the y-axis is A and C, and those are 2 points. So those are the 2 points, and you need to identify them. So we have A, 0, 3, and we have C, 0, -5. Those 2 points lie along the mirror line, which is the y-axis, and they will not change. We go to the last question in that section. Point 2.3 is enlarged by scale factor 4 about the origin. Find P prime, that is the image of P. So point P is enlarged by scale factor 4 and the center is the origin. Origin is 0, 0. Now for this one, there's a concept that you need to know. That for any enlargement with scale factor K, any enlargement of, let's say, a point XY, and the scale factor K, you simply, and the origin should be, in this case, this formula applies only if the center of enlargement is the origin, that is 0, 0. You simply take the scale factor and multiply each of the coordinates, the x coordinate, K multiplied by x, so that will be kx, and then K multiplied by y, that is ky. So you simply take the scale factor of enlargement and then multiply the 2 coordinates, that is the x and the y coordinates. So in this case, the point P is 2, -3, and the scale factor is 4. So you simply take 4 multiplied by 2, you get 8. 4 multiplied by -3, you get -12. So that will be 8, -12. That is P prime. And that is section A. Section B, answer all questions and is supposed to show all the workings in the blank spaces provided. Real numbers and reciprocals, that is question 21. Part A, from the list 12, 17, 25, 31, 39, and 49, write down all the composite numbers. I think we've gone through these in section A, and we gave the definition of a composite number. A composite number is that number that rather than having one and itself as a factor, it has other factors. in simple terms, we can say a composite number is a number that has more than two factors. So it has one as a factor, itself as a factor, and then any other extra factor. So we need to identify them here. So the first one I can see is 12. 12 has more than two factors. It can be divided by 12, that is by itself. It can be divided by 1 completely, then by 3 and by 4. So you can see those are so many factors. There are more than two. 17 is not. This one is a prime number. It has only two factors, that is 1 and itself. 25 has 25 is a factor, 1 is a factor, 5 is a factor. So that one is a composite number. 31 is a prime number because it has only two factors, that is 1 and itself. Then 39 is another composite number since it has 1 as a factor, 39 as a factor, and also 3 and 13. All those can divide 39 evenly or completely without leaving any remainder. That is what we mean by a factor. Then we have 49. 49 is also a composite number because it can be completely divided by 1, by 49, by 7. So you can see those are many factors. So those are the composite numbers. Part B. Classify each of the following as a rational or irrational. We also mentioned about these rational numbers. A rational number is any number that can be written in form of a over b, where a and b are integers and b should not be equivalent to 0. So we have 49. So we first list the rational numbers. The rational numbers, the first one is root of 49. How do you consider this? Because root of 49 is 7, and 7 can be written as in form of a over b as 7 over 1. And then root of 20 is not a rational. And then 0.27, also that one is rational. This is 0.2727. So this is 27 recurring. I mentioned earlier that this number, if you convert this number into a fraction, you'll notice that it is possible to express it in form of a over b. So we mentioned earlier and we said that rational numbers includes the repeating decimals and terminating, repeating or recurring decimals, and also repeating. But for irrational numbers are non-terminating and they are non-repeating or recurring. I think it's very important to note that as additional, apart from just defining what is a rational number and what is an irrational number. You need to understand that when it comes to those decimals that you find repeating or recurring, and then those that terminate, all those are part of rational numbers. But those decimals that do not terminate and they are non-repeating, they are non-terminating and they are non-repeating or non-recurring, those are irrational numbers. So that one is very important. So in this case, because we have 0.2727, this 27 is recurring. So we say for recurring decimals and terminating, they are part of rational. Then we can categorize now the irrational numbers. Irrational numbers are those numbers that cannot be expressed in form of a over b. And these ones are, we have the first one is root of 20. Root of 20, when you actually get the root of these, you'll find that this one will not terminate. It will not terminate. And also, it is not repeating. So it is non-terminating and it is non-repeating. So that one is an irrational number. And then we have pi. Also pi pi is in the same category because it doesn't repeat and it doesn't terminate. So it is non-repeating, non-terminating. So it is part of irrational number. So in this question, the rational number was root of 49, 0.2727, and then irrational, we had 20, root of 20, and pi. Part C, find the reciprocal of 2 and 2 over 5. So the reciprocal of these, first of all, this is a mixed number. So you convert these into an improper fraction, and these will get 5 times 2, that is 10, 10 plus 2, that is 12, divided by 5. So when you get the reciprocal of 12 over 5, this becomes 5 divided by 12. That's just one mark. We go to the next question, that is question 22, is about real numbers applications. So first one, part A, write 0.125 as a fraction in its simplest form as a fraction. So how do you write 0.125 as a fraction? These are decimal, and these are how you're supposed to do it. So you write it as 0.125 divided by 1. That is the same with 0.125. Writing it as a fraction is 0.125 divided by 1. Then from there, eliminate the number of decimal places. The numerator is written correctly with 3 decimal places, so you can multiply that by 1,000 to get rid of the decimal places. Then do the same for the denominator. Whatever you do for the numerator, do the same for the denominator. So when you multiply 0.125 by 1,000, you'll get 125. Then when you multiply 1 times 1,000, of course, you get 1,000. And then from here, you can actually simplify. You can simplify these by dividing the numerator by 125. You get 1. Divide 1,000 by 125, you get 8. So when you divide both the numerator and the denominator by 125, you'll get 1 divided by 8. We go to part B. A tap fills 3/4 of a tank in 36 minutes. Find the time required to fill the whole tank at the same rate. So a tap fills 3/4 of the tank in 36 minutes. Find the time required to fill the whole tank. So when the tank is full, the fraction will be 4 divided by 4, or 1. So 3/4 of the tank is filled using 36 minutes. What about when the tank is full, which is the fraction is represented by 1? So you just need to cross multiply. So you have 1 multiplied by 36, then divided by 3, divided by 3 over 4. So you can see this is a question on application of reciprocals. So you'll have 1 times 36 times 4 divided by 3. By 3, 1 by 3, this is 12. When you get 12 multiplied by 4, this will give 48 minutes. We go to part C. Using the digits 8, 1, 0, and 5, ones only, form the largest possible odd 4-digit number. You're supposed to form the largest, and that number should be odd, and it should have 4 digits. So it is very important to note that. Now, for this number to be odd, one thing that you must know, it must end with an odd digit. And amongst these digits that you can see here, the odd digits are 1 and 5. So now between the two, 1 and 5, which are you supposed to take? Now, since you want to form the largest possible, so you need to be very tactful in the number that you choose. I know most of the learners will go for 5 to be the last one. But now, if you go for 5, I'll put the two scenarios. If you say the last digit should be 5, so you'll be left with 8, 1 and 0. 8, 1 and 0. And because we want to form the largest possible number, of course, you will ensure that the first digit is big, followed by the next one, which is 1, and then followed by the next one, which is 0. Now, I'll give two scenarios. That is when you have the last digit as 5. Now, when you have the last digit as 1, you'll have 1 there, the last digit, and then you remain with 8 and 8. You remain with 8, 5, and 0. So you see now with those ones, to form the largest possible number, of course, you start with 8, and then you have 5, and then 0. So you can see between these two, the one that is ending with 5 and the one that is ending with 1, which is the largest? The largest is 8501, and this is the correct solution. So you could see when you form the number with the ending with 1, it gives the largest. But when you form it ending with 5, it forms the smallest. So between the two, 8501 is the biggest. Now you go to question 23. Question 23 is a question on indices. Part A, express 216 as a power of 6. So if you want to express this one as power of 6, so you just take 216 and then you will divide this by 6. Divide 216 by 6, you'll get 36. Then 36 divided by 6, you get 6. Then 6 divided by 6, you get 1. So this will be 6 multiplied by 6 multiplied by 6, which is 6 to power 3. So you have expressed that as a power of 6. Part B, you're supposed to simplify. This is where you're going to apply the laws of indices. So we start with brackets, of course. Anywhere you find there's a mixture of operations, you follow the Bodmer's law. So in this case, we'll start with the brackets. So for the brackets, you have 2 to power 5 multiplied by 2 to power negative 3. The law of multiplication, when the bases are the same, you add the powers. So 5 plus negative 3. And this gives 2. Then 5 subtract 3, you get 2. And this gives 4. But first of all, you may just leave it like that because you've not finished. So that is the bracket part. You are through with the bracket part. Now after doing that, you now take 2 to power 2. That is whatever you have solved, 2 to power 5 times 2 to power negative 3. And then now you divide with whatever we have here, which is 2 to power negative 1. So for this one, you are actually dividing. So use the law of division. When the bases are the same, you subtract the powers. So you get 2, subtract. You need to be very keen here with the integer, subtract negative 1. And this will give 2, then 2 plus 1. This negative and this negative, multiply negative and a negative, you get a positive. So this will give 2 to power 3, and 2 to power 3 is the same as 8. So that is what you get for that. Then question part C, evaluate 16 raised to power 3/4. 16 raised to power 3/4, you write it like that. So you're supposed to evaluate this. So what you do, you can express 16 in power form will be 16 in power form. You can raise the base of 2. So divide by 2, you get 8. 8 divided by 2, you get 4. Then 4 divided by 2, you get 2. Then 2 divided by 2, you get 1. So this will give 2 to power 4. 2 times 2 times 2 times 2. So 16 is 2 to power 4. And then you have to raise these to 3/4. So this gives you 2. Then you multiply the powers 4 times 3/4. And this will give by 4 1 by 4 1. So this one you get 2 cubed, and 2 cubed will give you 8 as the solution. So that is all for that question. We can go to the next question. We go to the next question. So the next question is here. question still on indices. Now the applications in solving. So you have the first one, 4 to the power x plus 1 is equals to 64. Now the first thing that you do is trying to express both the left hand side and the right hand side to the same base. Now is it possible to express 4 and 64 the same base in power form? Of course, yes. You have 4 power x plus 1, then you can write 64 in power form to the base of 4. So 64, you divide this by 4, you get this is a 16, then 16 divided by 4, you get 4, then 4 divided by 4, you get 1. So 64 written in power form with the base of 4 will be 4 cubed. Then with this, now that you've made both the left hand side and the right hand side to have the same base, you pick the power. So you have x plus 1, pick the power, is equals to 3. So you are simply equating the powers. But before doing that, you must ensure that the bases from both sides are the same, 4, 4. So this gives x plus 1 is equals to 3. And solving for x here, you subtract 1 from both sides. 3 subtract 1, you get 2. So that is the solution. Then part B, question on application. A bacteria colony doubles every hour. If there are 250 bacteria at the start, find the number of bacteria after 5 hours. So the most important thing you need to know is this part. The bacteria doubles every hour. Doubling means you multiplying it by 2. So you multiplying it by 2, that is double. And then every hour, we're going to let the number of hours to be n. So we're going to raise that to power n. So this is very important. So 2 represents the doubling. Then n, when you raise it to power n, n is the number of hours. So therefore, if there are 250 bacteria at the start, 250 bacteria at the start, find the number of bacteria after 5 hours. After 5 hours means you're going to multiply by, because it is doubling, multiply by 2, and that is after 5 hours. Remember, n is the 5 hours. 5 hours will be like that, to power 5. So that is what you need to work out. So this will give 250 multiplied by 2 to power 5 is 32. 2 to power 5 is 32. And this gives 200, just multiply this, 250 multiplied by 32. This gives 8,000. 8,000. 8,000. So you can see where we are applying the indices. It is this particular part here. 8,000 bacteria. Then the other question is question writing in standard form. You're writing in standard form. Write 0.00032 in standard form. How do you write any number in standard form? To write a number in standard form, you must express it in this form. A multiply by 10 to power n, where A should be less than 10. A should be less than 10. You're not supposed to make A to exceed 10. And A should also be greater than, it should be greater than or equal to 1. It should be greater than or equal to 1. So the value that you're going to choose here for A should be less than 10. And then it can be 1 or greater than 1. So that is very important. It should not be 10. So it should be somewhere between 1 and 9.99999. Actually, that is the easiest way. It should be between 1 and 9.9999. So when you look at this number here, if you put the decimal here where you have 32, you put the decimal at 3.2. You can see 3.2 is less than 10, and then it is greater than 1. It is greater than or equal to 1. Then times n should be any integer. N can be any integer. So 10. Now look at where you placed the decimal between 3 and 2. So now you count the number of steps to where the decimal was originally. Now that you have shifted the decimal point between 3 and 2, how many steps do you move either to the right or to the left to take it to where it was originally? Now on this, what you're going to do, you're going to move backwards. To go back to where the decimal was, you'll move backwards. How many steps? 1, 2, 3, 4. Since you're moving backwards or to the left, it will be negative 4 steps. And that is how you write that number in standard form. Question 25 is a question on logarithms, part A. Write 10 to the power negative 2 is equals to 0.01 in logarithmic form. So this number has been written in index form. You convert it into logarithmic form. Now in general, if you're given, let's say, a to power n is equals to m, that is in index notation, to convert these into logarithmic notation, you'll have to write it like this: logarithm of m to the base of a is equals to n, is equals to n. Now apply that in the question that you have here, and you will get this will be logarithm of 0.01, that is what is acting as m, that is what is acting as m, and the base is 10, the base is 10, that is the base, and that is a, is equals to the index, the index is n, and that is negative 2. So you have written that number in logarithmic form. So you need to understand the general way of how you write that, and then you will be able to write from either index form to logarithmic or logarithmic to index form. Part B. Given that logarithm of 2 to the base of 10 is equals to 0.3010 and logarithm of 3 to the base of 10 is equals to 0.4771, find logarithm of 60 to the base of 10. Now for this one, you have to be very keen on how you're going to split. You're going to write logarithm of 60 using whatever you have been given, using logarithm of 2 and logarithm of 3. So that is what you need to think about. How do you write 60 in terms of 2 and 3? In terms of 2 and 3. And this is how you write it. 60 can be written as 2 times 3, that is 6 times 10. That is why you have been given the logarithm of 2, then logarithm of 3. So therefore, logarithm of 60 can be written as logarithm of 2 times logarithm of 3 times logarithm of 10. And this one is to the base of 10, everything to the base of 10. And now from here you can split using the laws of logarithms, of which you need to understand. So this one you can split it. Logarithm of 2 times logarithm of 3 times logarithm of 10. You can split these and have logarithm of 2 plus logarithm of 3 plus logarithm of 10. We are using the basic laws in logarithm, and just to be specific on the exact law that I'm using is this one, that given logarithm of a times logarithm of b, then this is equivalent to logarithm of a plus logarithm of b. That is exact concept that I'm using here. Now From here, because you have logarithm of 2, you just substitute it there, 0.3010. Then logarithm of 3 will be 0.4771. Then logarithm of 10 to the base of 10 is 1. Logarithm of 10 to the base of 10 is 1. I talked about this in section A. When you have logarithm of A to the base of A is 1. Now with this, now you can add. So you have 0. You can add these. So just add everything. 0.30, 0.3010 plus 0.4, 0.4771 plus 1. I think I've made a mistake there. 0.3010 plus 0.4771 plus 1. This gives 7781. 1.7781 as the answer. We go to part C. Again, for part C, you given logarithm of 3 given there, then logarithm of 5 is given there. So you're supposed to evaluate these, evaluate logarithm of root of 45. So therefore, you need to think on how you're going to write logarithm of 45 using 3 and 5. Using 3 and 5. And don't forget that you're also getting the root. So let me first write 45 in terms of 3 and 5. So I can write it as 3 multiplied by 3 multiplied by 5. 3 times 3 times 3 times 5, that is 45. Then after that, don't forget that you're getting the root. And getting the root is the same as raising the number by a half. Getting the square root is the same as raising any number to power or to the index of a half. Now with that, now we can write it like this. Logarithm of the root of 45 can be written as logarithm of 3 times 3 times 5, like that. And since we said that, and I want you to note this carefully, that the root of 45 is the same as 45 raised to power a half. When you raise any number to power half, that is the same thing as getting the square root. Now having known that, so we can write this is a half, like that. And from the other law of logarithm, given that logarithm of a to power n, this one can also be written as n logarithm of a. This is another basic law that you need to also understand, very important, and that is what you're going to use here. So using this particular law here, this a half will come here, so that we have logarithm of 3 times 5. Don't forget the base. The base is 10. The base is 10. So then from here, we have a half, then multiply by, you can split these to have logarithm of 3 plus logarithm of 3 plus logarithm of 5. All these are to the base of 10. Don't forget that. All these are to the base of 10. Don't forget that. Now, having done that, now we can substitute. So we have a half, and then logarithm of 3 is 0.4771, like that. Sorry. Then logarithm of 3, 0.4771. Then logarithm of 5, 0.69. like that. So you have a half, multiply, you add everything here using a calculator. You can add everything there using a calculator, and when you add everything, 0.4771 plus 0.4771 plus 0.6990, you will get 1.6532. And this one simplifies to, when you divide that by 2, 0.8266. 8266 as the solution for that particular part. Question 26 is on logarithm applications. If logarithm of x to the base of 10 is equals to 1.6020 and antilog of 0.6020 is 4, find x. Find x. So you need to be very keen on how you approach this question. And one thing that you'll notice from here, from this one here, we can, because you're finding x, you can write these in index notation. Logarithm of x to the base of 10 is equals to 1.6020. If you write that in index notation, you'll get x to be 10 to power 1.6020. Ensure that you are quite familiar on writing from logarithmic notation to index notation, and also from index notation to logarithmic notation. So what I've done here, I have converted or written logarithm of x to the base of 10 is equals to 1.6020 in index notation. Now, with that, you'll notice something here. 10 to power 1.6020, you can split these and you'll get 10 to power 1 times 10, using indices of course, 10 to power 0.6020 is the same thing. So when you simplify these, it takes you back to that. Is the same thing. What we've done is just splitting, and you split that using the indices concept. Now with these, then it will be easier for us to proceed. We have 10 times, and since we are given the antilog of these to be 4, the antilog of 0.6020. So if you want to get the antilog of these, the antilog of these will give us 4. If you want to get the antilog, because you're finding x, that means we are supposed to get the antilog. So when you get the antilog of 10 to power 0.6020, that gives you 4. And now the solution will be 10 multiplied by 4, which is 40. So that is exactly how you're supposed to solve that question. We go to part B. You're supposed to use logarithms to evaluate 24 times 15, and you're given the log of 24, the log of 15 to the base of 10, and also the antilog. So the easiest way, I'm going to use a table, number, and then I don't need to write the standard form because already the log is given. It is already given, it is there. So this is how you're supposed to do it. So you have 24. The logarithm of 24 is given as 1.3802. Then logarithm of 15 is given as 1.1761. When you're multiplying the numbers, you add their logarithms. When you add, you get 3, 6, 15, 5, and then this one gives you 2. After you've done that, now to get the answer, you get the antilog. You get the antilog of 2.5563. So the antilog of the characteristic. Remember, this has two parts. So 2 is the characteristic, then the decimal part 0.5563, that is the mantissa. So get the antilog of 2. The antilog of 2 is 10 to power 2. Then the anti-log, and this is what we are given. The anti-log of 0.5563 is given here. That is why it is given. It is given as 3.6. So that is given as 3.6. So when now you get this product, this will be the solution, and this is the same as 3.6 times 100, and this gives 360 as the solution. Question 27. Question 27 is a question on quadratic expressions. Part A, expand and simplify. Expand and simplify. So you have 2x subtract 3 multiplied by x plus 4. So this is how we go about it. So you take 2x, then multiply by the second bracket, which is x plus 5. Then take negative 3, that is the second term there. Multiply by the second bracket, which is x plus 5. And then from there, open the bracket. 2x by x, you get 2x squared. 2x multiplied by 5, you get 10x. 3 times x, that is negative 3x. And the negative 3 times 5, that is negative 15. Then collect the like terms. So you have 2x squared. 10x subtract 3x, you get 7x. Then subtract 15. And you have expanded and you have simplified. Part B, factorize completely. Factorize, you need to know the difference between expanding and factorizing. So what we've done in the first part is expansion. Now we need to factorize. So factorize this. Now for you to factorize, you need to get two numbers whose product is the coefficient of x squared is 1. Then the constant term is positive 30. So product, that is 1 times 30. 1 is the coefficient of x squared. Then the constant term is 30, and it is positive. So look for two numbers whose product is 30. And the sum should be the coefficient of x. The coefficient of x is positive 11. So these numbers are 5 and 6. You add them, you get 11. Multiply them, you get 30. After that, now take x squared plus 11x, write 11x using 5 and 6. So 11x will be 5x plus 6x plus 30. Then you factorize x plus 5 plus 6, x plus 5. You factorize what is common between x squared and 5x. It is x. Factor out x. Then what is common between 6x and 30? It is 6. You factor out. When you expand whatever you have here, it should take you back to that. If it doesn't, you should know that there is an error that you've made. X times x, x squared, x times 5, 5x, 6 times x, 6x, and so on. Then from there, once you this stage, you simply finalize and take x plus 6 multiplied by x plus 5. And that is the final solution. So you have factorized. So you can see the difference between expanding and factorizing. State the coefficient of x. The coefficient of x, we just said that the coefficient of x is the term that is multiplying x. And the term that is multiplying x here is negative 7. Not 7, but negative 7. You have to pick that sign before 7. That is what is multiplying x. That is what we refer to as the coefficient of x. The coefficient of x squared, if that was the question, could have been 3. If the question had asked maybe what is the coefficient of x squared, could have given 3 is what is multiplying x squared. We go to question 28. Question 28 is a question on quadratic identities. Quadratic identities. Expand x subtract 4 squared, x subtract 4 squared. We need to expand these. So this means x subtract 4 squared means x multiplied by 4. X subtract 4 mean then x subtract 4. That is what we mean by x subtract 4 squared. It is x minus 4 squared. And when you expand these, you get x take x, multiply by the second bracket, which is x subtract 4, then take negative 4, multiply by x minus 4, and this gives x times x, x squared, x times negative 4, negative 4x, then negative 4 times x, this is negative 4x, negative 4 times negative 4, that will be positive 16. So you have to be very keen with these. X times x, x squared, x times negative 4, negative 4x, negative 4 times x, negative 4, x, that is negative 4 times negative 4, positive 16. Then the like terms, so you have x squared, negative 4 subtract negative 4x, subtract 4x will be negative 8x. You need to be very keen there with the integers, and that is the expansion. Then you go to part B, factorize 9a squared, subtract 25 completely. So when you look at this keenly, this is difference of two squares. And for difference of two squares, remember that if you have a squared minus b squared, this is what we refer to as difference of two squares. You have one square that is a square of a, and then you're subtracting the square of b. So you are simply getting the difference of two squares. So in such a case, to factorize that, you simply take a plus b, a minus b. You multiply that. Now use that for this particular one here. So when you look at what you've done here, in simple terms, if you have the square of a as a squared, then its square root will be a. We have b squared, you get the square root of b squared, that will be b. So you have 9a squared, 9a squared. What did you multiply with itself to get 9a squared? It is actually 3a. If you get the square root of 9a squared, it will be 3a. So let me write the whole thing here. So 9a squared subtract 25 will be given by the square root of 9a squared will be 3a, then plus the square root of 25 will be 5, then 3a minus 5. It's as simple as that. So we've applied the knowledge on the difference of two squares. So you simply just check out these. This is one square, so that is a square of 3a, and this is a square of 5. So that is what has helped us to arrive to this. Part C, find k if x squared minus 18x plus k is a perfect square. So if this is a perfect square, then this is how you get the last term. So in a quadratic expression, you have the first term, the middle term, and the last term. In a general quadratic expression, let's say ax squared plus bx plus c. This is a general quadratic expression. If you want to get the constant term is obtained by getting the coefficient of x, which is b, get half of that, half the coefficient of x, and then you square. That gives you the constant term. So in this case, what is c? C is equivalent to k. So k will be given by the coefficient of x. The coefficient of x is negative 18. Whatever is multiplying x, that is what we refer to the coefficient of x. It is negative 18 and not positive 18. So negative 18, then you divide by 2, and then you square. So this will be negative 9 when you divide that, and this will give 81. When you square negative 9, you get negative 9 times negative 9, which will be 81. Question 29 is a question on quadratic equations, how to solve them. So you're supposed to solve x squared minus 7x plus 10 is equals to 0. So how do you go about this? Number one, you have to factorize, and then after factorizing, then you solve. So we factorize x squared subtract 7x plus 10. And this is how we factorize it. You get two numbers whose product is 10, because the coefficient of x here, I can see it is 1. So the product should be 10, and the sum should be -7, the coefficient of x. So which are these numbers? These numbers are -5 and -2. So having got that, now we can proceed and get x squared. Then we write -7x using -5 and -2. So these will be -2x, -5x, that is -7x, and then plus 10 is equals to 0. Then from there you factorize between x squared and -2x. What is common? X is common, so you have x subtract 2. Between -5x and 10, -5 is common, so when you factorize -5, you remain with x subtract 2. You need to be very keen when it comes to factorization here. Then from here you now take x subtract 5, multiply by x subtract 2 is equivalent to 0. Now you're multiplying two numbers and the solution is 0. So that means it is either x subtract 5 is equals to 0, and in this case x will be 5, or x subtract 2 is equals to 0. So here x is equals to 2. So those are the solutions. X is equals to 5 and x is equals to 2. Now the second one has a difference, because now for this one, part B, you can see you have 2x squared subtract 5x subtract 3. So when you're getting now the product, you look for two numbers whose product is the coefficient of x, which is 2, x squared, that is, the coefficient of x squared is 2, and then the constant term is -3. So you look for two numbers whose product is -6, and their sum, the coefficient of x, which is -5. So which have these numbers? When you multiply them, you get -6. When you add them, you get -5. So which are these numbers? When you think about these numbers, you get the numbers will be, let me think, this is about -2, -2 and 3, -3, no, that one will not give. 2 and 3, I'm thinking of 2 and 3. So you have 2 and 3, -2 and -3. Product will not give negative, of course. So that means one of them has to be positive and another one has to be negative. You have to be very keen, take your time to look for these two numbers. And one is -6 and the other one is 1. That is a perfect one. -6 times 1, -6, and then -6 plus 1, -5. So the numbers are -6 and 1. So having obtained that, now you come here, 2x squared. Then -5x is what you're going to write using -6 and 1. So that will give -6x plus 1x. Don't write 1x, just write x. Then subtract 3 is equals to 0. Then factorize between 2x squared and -6x. What is common? So 2x is common. So you'll have x subtract 3. When you factor out 2x, you remain with x subtract 3. And then plus, what is common between x and -3? 1 is common. 1 is common. So you have x subtract 3. Like that. So this one simplifies to 2x plus 1. So 2x plus 1, and then x subtract 3 is equals to 0. Now after that, now you have two numbers that you're multiplying. So it is either 2x plus 1 is equals to 0. So if you solve for x here, you'll get x as take +1 to the other side, so it will be -1, and then you divide by 2, so negative a half. Or x subtract 3 is equals to 0, so x will be given by take negative 3 to the right hand side, or add 3 to both sides. These will be 3. So those are the two solutions. You can solve question 30, quadratic equations in context. This application of quadratic equations. A rectangular kitchen garden has an area of 112 meters squared. Its length is 6 meters more than its width. Let the width be x meters. Form a quadratic equation in x. So this rectangular kitchen has an area of 112. The length is 6 more than width. So if the width is x, then the length is 6 meter more. The length is 6 meter more, though, so it means it will be x plus 6. So if you're letting the width to be x meters and the length is 6 meters more than the width, so the length will be x plus 6. And you're given the area. So how do you get the area of this rectangular kitchen? It is length multiplied by width, which will be given by the length is x plus 6 multiplied by x, which is the width. That should give 112. You're supposed to form a quadratic equation. So x multiplied by x will be x squared. X multiplied by 6, that will be 6x. And then when you subtract 112 from both sides, you'll get 112 negative is equals to 0. So you just taken this one to the other side by subtracting 112 from both sides, because a quadratic equation has to be in this form: ax squared plus bx plus c is equals to 0. This is a standard equation, standard quadratic equation. So that is how it should be. Then you're supposed to solve that equation and hence find the dimensions of the garden. So we solve these. So how do we solve these? X squared plus 6x minus 112. So we're going to use a factorization method. So look for two numbers whose product is the coefficient of x squared is 1 and the constant term is negative 112. So you're looking for two numbers whose product is negative 112 and their sum should be the coefficient of x, which is 6. So which are these numbers? You have to think, You have to think about them, So these numbers, you really have to think about them. So these numbers will be, if we take, for instance, negative 8, and 14. So negative 8 times 14 will be 112. Negative 8 plus 14, that will be 6. So the numbers are negative 8 and 14. Now having those numbers, so now you have x squared, then plus 6x, you write it using negative 8 and 14. So it will be 14x minus 8x, then minus 112 is equals to 0, like that. And you can proceed now and factorize between x squared and 14x. What is common? X is common. So you have x plus 14. Then between negative 8x and negative 112, what is common? Negative 8 is common. So you have 8 then plus 14, like that. Then from here you have x subtract 8, then x plus 14 is equals to 0. So at this stage, it is either x minus 8 is equals to 0. And if that is the case, if you solve this equation, x minus 8 is equals to 0, x will be 8. And also, x plus 14 is equals to 0, x will be negative 14. So you have two values of x, and since x refers to the dimension, which is the width will not be negative. Measurements can be negative, so you ignore the negatives because this is the length. You take the absolute or the positive, you ignore the negative. So therefore the width is now I'm writing the dimensions. Width is equals to 8 centimeters. Then the length, remember the length was 6 meters more, so it will be 8 plus 6, so it will be 14 meters. Is it meters or centimeters? Yeah, it is meters, so it is meters. So this is supposed to be meters. So these are the dimensions, 8 meters and 14 meters. And then the last question, which is very straightforward: find the perimeter of the garden. So perimeter of a rectangle is given by 2 into length plus width, or you add the total distance around that rectangle, so it will be 2. The length is 14 plus the width, which is 8, and this will be 2 times 22, and that one gives 44 meters. Question 1. Two similar models of a water tank have corresponding heights 12 centimeters and 18 centimeters. Find the linear scale factor from the smaller model to the larger model. So you're supposed to find the linear scale factor from the smaller model to the larger model. So you need to understand that, and we found a similar question in section A on the same. So this ratio is supposed to be this way: the linear scale factor from the smaller to the larger model. So that means we will start with the larger in the numerator, then divided by the smaller. So in this case, we have the larger as 18, and then we have the smaller as 12. And when you work out these, this is supposed to give 1.5. Or you can just give it a 3/2. Is still another way you can give it. So you can write it as just a little bit here. So you can write it as 3/2 or 1.5. So the two are okay. So that is the linear scale factor. Part B, the other two dimensions of the smaller model are 8 centimeters and 10 centimeters. Find the corresponding dimensions of the larger model. So you're given the dimensions of the smaller model as 8 and 10. So you're supposed to find the corresponding dimensions of the larger model. Now that you have the linear scale factor, which you have obtained, larger divided by the smaller, that is the linear scale factor, we shall use these to get the corresponding dimensions of the larger model. Remember, the numerator represents the larger model, then the denominator the smaller. So in this case, we shall take so both of these are smaller models, 8 and 10. So when we have the dimensions as 8 centimeters, that is on the smaller model. The smaller model is the numerator. What will be the dimension of the larger model? So you let the dimensions of the larger model to be x. Then the smaller model, of course, it is 8. So you work out x by cross multiplying. So 2 times x, this will give 2x is equals to 3 times 8, which is 24. And therefore, the dimension of the larger model will be, for this one will be 12 centimeters. Then we do the same for 10. So we use the same linear scale factor is equals to, now the larger model, the smaller model measures 10. Then what about the other dimensions of the corresponding dimension of the larger model? So the smaller model, 10. What about the larger model? We let that run to be x. So we work out these. And remember, when you're using this ratio, you're using the larger divided by the smaller. So the larger is in the numerator, then the smaller is in the denominator. So we multiply this 2 times x. 2 times x, of course you get 2x is equals to 3 times 10, that is 30. So you have x to be 15 centimeters. And therefore these are the dimensions. The dimensions are 12 and 15. So 12 centimeters and 15 centimeters. So those are the dimensions. We proceed to part C. If the volume of the smaller model is 640 centimeters cubed, find the volume of the larger model. The volume of the larger model. So for this one now you have to use a volume scale factor, and for you to work out this question you need to understand the relationship between linear scale factor and volume scale factor, and this is the relationship. Linear scale factor cubed gives the volume scale factor. So already we have the linear scale factor as 3 over 2, 1.5. So it is there, 3 over 2. So when we get the cube of these, it is going to give us the volume scale factor. The volume scale factor is the ratio of the corresponding volumes of these two models that we have here. So this will be 3 cubed, which will give 27, then 2 cubed, which will give 8. So the volume scale factor is 27 divided by 8. Again, it is important to note that 27 represents the volume of the larger model, then 8 represents the volume of the smaller model. So now we can equate 27 divided by 8 is given by the volume of the larger model, of which we are not given. That is the question, that is what you're supposed to find. We let it to be x, then divided by the volume of the smaller model, which is 640. So once we work out these, now we shall be able to get the volume of the larger model. So cross multiply 8 times x, you get 8x is equals to 27 times 640 times 640. These will give 17,280. Then to get x, you simply divide both sides by 8. So when you divide that on by 8, that gives 2160 centimeters cubed. So that is how you're supposed to work out that question. We go to question 32. Is a question on enlargement. Triangle PQR has vertices P11, Q41, and R13. It is enlarged by scale factor 2 about the origin. Draw triangle PQR and its image after the enlargement. Write the coordinates of P prime, Q prime, R prime, and then you're supposed to use a graph paper at the back. So we have this triangle. It is enlarged by scale factor 2. So the first thing is plotting. So we plot P11. So start by drawing the axis. So let me draw the axis very fast. So those are the axes. So we have the y-axis is here, and then this is the x-axis. So make sure you've drawn the axis, and then you have numbered 1, 2, 3. I've numbered up to 10. I don't think it will go beyond that. Now we need to plot P. P is 1, 1. P is 1, 1. So P is 1, 1. So it is here. That is why you have P. And then Q41. Q is 4, 1. So it's there. And then R is 1, 3. R is 1, 3. So it's supposed to be there. So let me join. Join using a ruler. So there we have triangle PQR. Once you've done that, The next thing is enlarging that by scale factor 2, and the center as the origin. So the center is the origin. So the center is the origin. The origin is 0, 0. So this is the center. So this is how we get the image. So join every point to the center. The center of enlargement is 0, 0. So we start with P. Join that using a straight line. Take a ruler. So from the origin, that is from 0, 0, join that using a straight line like that. Straight line like that. And then you can now get the distance. Get the distance now to get the image of P from the center. So you started by joining P to the center of enlargement, which is 0, 0, and then you extend that line. Then to get the image of P, this is what you do. Count the distance or measure the distance from the center of enlargement to the object. So from O to P, that is just 1 square. That is just 1 square. Because we are enlarging by 2, we shall count 2 squares from O, or from the origin, that is 0, 0. So from origin to P, that represents enlargement by 1. So if you want enlargement by 2, which is double, we're going to add another 1 square. So we count from here, you have 1, 2. So 2 will be here. So that is why we mark the image of P. So the image of P will be here. So we've counted from here 1, 2. We're done with that. We go to Q. So for Q, we do the same. Take a ruler, and then from the origin, join from the origin, draw a straight line through Q and make sure you extend that line. Then now to get the image of Q, get this distance from O to Q, from the center of enlargement, which is the origin, to Q. Then you double that distance. So you can see these are how many squares? These are from here we have 1, 2, 3, 4. So that means because we are enlarging these by 2, we are going to get double that distance. So from the origin to Q, we've got those are 4 squares. So we double that. So we shall count 8 squares from the origin. So these are 1, 2, 3, 4, 5, 6, 7, 8. So this is why we shall have Q, 8. That is Q prime. All the same, you can decide to use a pair of compass for that as well. So if you don't want to count the number of squares, you can use a pair of compass like I'm doing here. And then what you need to do is just get that distance. So that represents enlargement by 1. That is enlargement by 1. So now you have to double that distance. And when you double that distance, that is when you shall find the point will be there still. So you double that distance. So you can still measure that distance using a pair of compass. So now the last one is R. So you join R, the center, enlargement like that, and make sure you extend that line completely like that, and then count the distance from the center to R. So how many squares are these? From these you have 1, 2, 3. So you're enlarging by 2, so you double that distance. So you're going to count from here 1, 2, 3, 4, 5, and 6. So this is where we shall have R. So R will be here. So R prime will be there. Now you join the points. So now join. So use the red. So from P to Q, and then from Q to R, then R to P, like that. So there we have the object and the image. So we have the object, you can see it is enlarged by scale factor 2. So we've done that. So we write the coordinates. We've not finished. We write the coordinates of P prime, Q prime, and R prime. So which are the coordinates? I'll write the coordinates here. So P prime, these are how you write the coordinates. P prime is here. So we have it here. So this is a 2, 2. Then Q prime is here. This is 8, 2. And then R prime is here. So this is a 2, 6. So this is how you're supposed to write the coordinates for that part. Part B, find the area of triangle PQR and hence find the area of its image. So you're finding the area of the object and the image. So when you look at these figures, both of them are right angle triangles. So we can simply use the formula of half. So we start with the PQR. We can use this formula half base times height, because it is easy to identify the base and the height by just counting the number of squares. So we have a half. The base is from P to Q. From P to Q, how many squares are these? 1, 2, 3. There are 3 squares. And then the height from 1 to 3, those are 2 squares. So this gives 3 square units. 3 square units. So what about for the image? P prime, Q prime, R prime. So the same thing, a half times the base. The base will be P prime, Q prime. How many squares are these? 1, 2, 3, 4, 5, 6. There are 6. And then the height, 1, 2, 3, 4. 4. So by 2, 1 by 2, 2. So this gives 12 square units. 12 square units. Still, you can use another method. You can use the linear scale factor, the relationship between linear scale factor and area scale factor. Still, that one can give you. But since for this one, the shapes are clear and they are right angle triangle. You've drawn them on a graph paper and it is easy to measure the angle. These are right angle triangles and it is easy to get the area. All right, we can go to the next question. Part C, state one effect of a positive scale factor greater than 1 on a plane figure. So what is the positive effect of a scale factor that is greater than 1? We have 2 types of scale factor. One is greater than 1, and then we have another scale factor that is less than 1. So when a scale factor is greater than 1, the effect is that it enlarges the object. It enlarges the object. It enlarges the object. And if, let's say, it is less than 1, let's say maybe it is a half. If the scale factor is a half, it reduces or it makes the object, the image, to be smaller than the object. But if the scale factor is greater than 1, it enlarges the object, and therefore the image becomes bigger becomes bigger than the object, That is the same thing, but just saying it enlarges the object is just the same thing. So if, let's say, the scale factor is negative, what is the effect? If it is negative, let's say -1, the difference is that the object and the image are on the opposite sides of the center of enlargement. That is, when the scale factor is negative, the object and the image are on the opposite sides of the center of enlargement. Question 33. Reflection on the coordinate plane. Use the graph paper below for your drawing. Draw the coordinate axis through the center and use one bold square as 1 unit. So this is a graph paper. So let me draw the axis through the middle, through the center. It's not a must you do this. The marks can be awarded. Doesn't need to be exactly at the center. Sorry for that. So use a ruler for this. So this is the axis. So we have the y-axis and we have the x-axis. So we have 0 there. We have 1. We have 2. We have 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5. So part A, on the graph paper, draw the coordinate axis through the center. Plot A, -3, 1, -3, 1. So -3, 1 is here. -3, 1 is here. That is A. And then B, -1, 1. B is here. -1, 1. And then C, -2, 4. C is -2, 4. So it is there. Then, of course, from there you can join them. And you form the triangle like that. So once you've done that, part B, reflect triangle ABC in the y-axis and draw the image A prime, B prime, C prime. Reflect triangle ABC. Reflect that. The y-axis should act as the mirror line. So we get the image. So the y-axis is the mirror line, and you need to understand the property of reflection. The mirror line is exactly located between the object and the image. So we shall get the image of each point. We start with A. So A is here. The mirror line is here, the y-axis. So we're going to count the number of units square from A to the mirror line. So we have from A, we have 1, 2, 3 squares. So from the mirror line along that straight line, because that is what you're supposed to do. So you draw a straight line like that, just to explain. So you count, these are 1, 2, 3. Then from here, 1, 2, 3. So you're going to stop at this point. So this is why we shall have the image of A. A prime will be there. This property that you're using here is that the distance between the mirror line and the object point should be equidistant, should be the same with the distance from the mirror line to the image. So this is what I mean. So from A to the mirror line, that distance is 3 units. So from the mirror line to A prime, the distance should be the same. It should be 3 units as well. And this line that is connecting A to A prime should meet the mirror line at 90 degrees. It should meet the mirror line at 90 degrees. It should be perpendicular. So we do the same for B. For B, we use the same line. So from B to the mirror line, 1 unit. So the image of B will be here. So from the mirror line, just count 1 unit. So we shall have B here. So B prime is there. B prime is there. And then C, we do the same for C. I can draw that line. For C, count the number of squares from C to the mirror line. Those are 2. So from here, you have 1, 2. So it will be here. It will be here. So C prime will be there. So now you have the image point. So you have A prime, B prime, C prime. So simply join them using a ruler. So now you can see that this is the image, this is the object. The mirror line is exactly between. It acts as the line of symmetry between the object and the image. The mirror line is here between, and each point, look at B, the image of B, they are directly opposite each other. That is another property of reflection. So that is exactly what you're supposed to do. Then the last question, write the coordinates of A prime, B prime, C prime, the coordinates. So the coordinates of A prime is 3, 1. Then B prime is 1, 1. And then C prime is 2, 4. 2, 4. 2, 4. Just like that. 2, 4. So those are the coordinates, and that is how you're supposed to solve that. So you get 2 points for that. And then of course for the other one, you're supposed to get 3 marks for part A. Oh, I wrote the coordinates. So we did the reflection. So this is supposed to be here. It's still okay. So I've written it in the wrong place. So the image points A prime 3, 1, B prime 1, 1, and C prime 2, 4, like that. So question 34, part A, state the SAS congruence condition. This condition states that when you have 2 corresponding sides in 2 triangles and an included angle, then the 2 triangles are said to be congruent. So it means that 2 sides, 2 corresponding sides, 2 corresponding sides, and an included, or the angle between the 2 sides, an included angle, So that is the condition. So when you have two triangles and you have two sides that are corresponding, that are equal, two corresponding sides and an included angle, then it means that the two are congruent. So these two corresponding sides must be equal. They must be equal. Actually, let me state that clearly here. For the two corresponding sides, are equal, and a common and unincluded angle are equal. So a very good example, I can draw it here. This is what we mean by SAS. You have these two. So we have those two. Let me draw a better one. So you have this side as 6, this one as 5. This is 6, this is 5. And then there is an angle. Let's say that angle is 60. This is the condition that we're talking about. So where we have two corresponding sides that are equal, so you can see 6, this side corresponds with this. Then you have this 5 corresponds with this. And then there is also angles, two angles that are corresponding, that are equal. Two angles that are equal, 60 and 60. This is the condition, SAS. Let's go to the other one, part B. In triangle ABC, the sides AB and AC are equal. AB is equals to AC. A line is drawn from the vertex A to meet the base BC at point D, such that AD is perpendicular to BC. Prove that the triangle ABD is congruent to triangle ACD. So let me draw that. So that is a triangle, and the triangle is named as A, B, C. So a line is drawn from the vertex to meet BC at D, such that AD is perpendicular. So is a line that is drawn here, such that to meet this is D and this is perpendicular. So on a given AB is equals to AC, AB is equals to AC, you're supposed to prove that ABD is congruent to ACD. So which condition are we going to use to prove these? We're going to use these RHS, where you have the right angle. We have to indicate this, the right angle. There is 90 degrees in both of this triangle, and that angle is ADC. So angle ADC is equals to angle ADB, which is 90 degrees. That one satisfies the condition of right angle in the two triangles. And then we have the hypotenuse. Hypotenuse is given there. AB is equals to AC. So that is another marking point. So for this one, you can see the question has 3 marks. So that is 1 mark. Then this one is another mark. And then the last one is the side. We have the side. So we must prove. So there is a side that we must prove. This is S. So there is a common side. AD is common in both of these triangles. So when you look at triangle ADB and ADC, they are sharing a common side. So AD is equals to AD in both. That is a common side in both triangles. Common side. So those are the 3 ways you're supposed to have proven using this condition RHS, right angled, hypotenuse, and common side. Then part C, give one reason why congruent triangles have equal areas. Give one reason why congruent triangles have equal areas. The reason is simple. It is because they have equal corresponding sides. They have equal corresponding sides, and angles, corresponding sides and angles, and so their areas should be equal. So if they have equal corresponding sides and also equal corresponding angles, then their areas should be equal. The last question is on mixed reasoning and transformation scale factors. A school badge is first reflected in a vertical mirror line and then enlarged on a photocopier by scale factor of 3. Which of the two transformations produces congruent image? That means the image that is produced is of the same shape and size as the object. That is what we mean by congruency. So which of the two? So between enlargement and reflection does not change the shape and the size of the object. So reflection is the solution there. Reflection is the one that is going to produce congruent image, because reflection does not change the size and the shape, but for enlargement it changes the size by either making the image to be smaller or bigger. So the reflection is the one that produces. So the solution there is reflection. If you just indicate a reflection, it is okay. But B, if the original badge has an area of 24 centimeters squared, find its area after enlargement by scale factor 3. So in this part, we have two things. The scale factor that is given here is the linear scale factor. So linear scale factor, we will take that as 3:1, or simply 3/1, or 3/1. And for linear scale factor, we need, because we want to get the area scale factor, we need to know the relationship between linear scale factor and area scale factor. So linear scale factor squared gives area scale factor. So if we have the linear scale factor is 3, then the area scale factor should be the square of that. So it should be 3/1 squared, which will give 9. So area scale factor will be 9. Now, if the original badge, we take the original badge to be the object, if it was 24, and you're supposed to find the area after it has been enlarged, so we're going to multiply that by the area scale factor, which is 9. We multiply that by 9, and that should give 216. 24 times 9, that should give 216 centimeters squared. So first of all, we needed to know the linear scale factor. When you get area scale factor, then you take the area scale factor, multiply by the original area of the badge. Part C, if an enlarged side is 18 centimeters, find the corresponding original side. If the enlarged side is 18 centimeters, so that means this is the image. So remember the linear scale factor. The linear scale factor was 3:1. So in this case, I have used the image divided by the object. So 3 represents the image, 1 represents the object. So if it is enlarged, that becomes the image. So 18 represents the image, and then the object, which is the original side, should be represented by x, because I don't know that. That is what I'm looking for. So when you cross multiply 3 times x, you get 3x is equals to 18 times 1, which is 18. And this one gives x to be 6 centimeters. It gives 6 centimeters. Then the last question, give one property preserved under reflection but not enlargement. So you need to understand between reflection and enlargement. So under reflection, the object and the image are of the same shape and size. Actually, for a reflection, it produces the exact image as the object. But for enlargement, it either increases the length or it increases the object to get a bigger image or a smaller image. So the property that is preserved under reflection, one is the size. You can indicate the size of the object is preserved, or you can talk also of the length. The length of the object is preserved. That is why when you look at the image, for instance, what we had here, this is a very good example of a reflection. So look at ABC and A prime, B prime, C prime. They are actually of the same shape and size. All the lengths have not been interfered with. They remain the same. And also the size of the object and the image are the same. So those are the two things that are preserved, the size and also the length. We just needed to give one, and that is all. Remember to check the paper in the description. I've provided the link. And also, just to remind, for those who have not accessed all the grade 10 projects, I've also attached a link that you can use to download all the grade 10 projects. Thank you so much.